The theory of the very first stars, known as population 3 stars, is a fascinating chapter in the story of our universe. These stars, born in the nascent cosmos, played a critical role in shaping the subsequent evolution of the universe. They were unique, unlike any stars we see today, because they formed from the primordial gas that existed after the Big Bang, devoid of any elements heavier than helium. The primordial universe. After the Big Bang, the universe was a hot, dense plasma of particles. As it expanded and cooled, protons and neutrons combined to form the first atomic nuclei, primarily hydrogen and helium, with trace amounts of lithium. This era, known as Big Bang nucleosynthesis, ended roughly 20 minutes after the Big Bang. The universe then entered the Dark Ages, a period before the formation of the first stars, when it was filled with a nearly uniform gas of hydrogen and helium atoms. Gravitational collapse. The formation of the first stars began with tiny density fluctuations in the early universe, which grew under the influence of gravity. These fluctuations caused regions of slightly higher density to collapse, pulling in more matter and growing denser over time. As these regions collapsed, the gravitational energy was converted into heat, increasing the temperature and pressure in the core of the forming stars. Population 3 stars. The first stars are classified as population 3 stars, distinguishing them from later generations of stars, which are classified as population 1 and 2 stars. Population 3 stars were composed almost entirely of hydrogen and helium, with virtually no metals. This lack of heavier elements profoundly affected their structure, formation, and evolution. Mass and lifespan. Due to the inefficient cooling mechanisms in the primordial gas, population 3 stars were likely very massive, with estimates ranging from tens to hundreds of times the mass of the Sun. These massive stars had short lifespans, burning through their nuclear fuel quickly and living for only a few million years compared to the billions of years that smaller stars like the Sun can live. Brightness and temperature. Population 3 stars were incredibly bright and hot. Their high mass and temperature meant they emitted large amounts of ultraviolet radiation, significantly impacting their surroundings. This radiation began the process of reionization, ionizing the neutral hydrogen in the universe and making it transparent to ultraviolet light. Supernova explosions. The massive population 3 stars ended their lives in dramatic supernova explosions. These explosions were crucial for enriching the surrounding gas with heavier elements, a process known as nucleosynthesis. The first supernovae produced elements like carbon, oxygen, and iron, seeding the universe with the raw materials for the next generations of stars and planets. Chemical enrichment. The supernova explosions of population 3 stars played a critical role in the chemical evolution of the universe. By enriching the interstellar medium with metals, they enabled the formation of population 2 stars, which in turn produced more metals, leading to the formation of population 1 stars like our Sun, which have even higher metal content. The theory of the very first stars, or population 3 stars, is a cornerstone of our understanding of the universe's evolution. These stars, born from the primordial hydrogen and helium created in the Big Bang, were the universe's first sources of light and heavy elements. Their formation, characteristics, and dramatic deaths in supernova explosions set the stage for the subsequent generations of stars and the complex, structured universe we see today.